Okay, we're back with lab number 13, the final lab, and our cabbage sensors have dried. This is the paper towel with that anthocyanin dried on it, and that's what we're using as our cabbage sensors. Now in your lab you're going to be comparing this type of sensor to store-bought pH sensors. I went to Walmart, my not favorite place, but the place where they have just about everything, and I know there are Walmarts where most of you live. So this was about $5, and it comes with 5 test strips that you can use to test for pH. I also tried out this brand. It comes with, also from Walmart, 2 little kits. It tests many other things about water other than pH, so feel free to experiment with that, explore chemistry in that way. This cost $15. So I bought both. I'm going to test out both. You can find whatever type of universal pH test strip you can at either some kind of hardware store or at some other type of store. And they both come with color charts so that you can look and compare the color to determine the pH. Now the cabbage sensor, obviously you made it, so it doesn't come with a chart. But in your lab book on Blackboard, I posted a color chart, so you can use that to determine whether your sample is acidic or basic. As a general rule of thumb, if it's acidic, this sensor will turn red. If it's basic, it will turn blue. So here we go. I'm going to go ahead and test each of the sensors. The samples I'd like you to test are vinegar, baking soda, mixed in water, lemon juice. You may already know if something you see here is acidic or basic. Dish soap, and hydrogen peroxide, which is something you used in a previous lab, so you should have it. So we have 6 samples. Okay, so what I want you to do is note down the color that you see and the pH, the best way that you can tell. So you're going to do this for 2 different sensor types. I have 3 here because I'm exploring 3 options, and let's fill them in as we go. So for the vinegar, I'm just going to get my system set up here. Okay, and we're all set up to test vinegar. So I just took some of my white vinegar from the previous experiments and poured a little in the cap. That's really all you need. So here's our cabbage sensor. And what color do you see? It immediately turns pinkish, reddish. If I put it against a white background, you can see that. So then you can see the rest of the sensor is more bluish in color. So I'm going to go ahead and say that I believe vinegar is acidic because of the red color on the cabbage sensor. So I'm going to note down pink, red, and the pH, I believe, is acidic. And I can't really be too specific about the pH right now. If you look at your color chart on Blackboard, you can guess about the specific pH. But we're going to find the cabbage sensors. Well, actually, I won't give it away. Okay, so we have a red color. I'm guessing it's acidic. Okay, now the next sensor type. This came from the area where they sell things to test fish tanks, because a lot of people have to test their fish tanks for pH. Okay, so it says we're going to leave that for 15 seconds to develop its color. It looks already like it's pretty close to the low end of the scale, which they're giving you a pH of 6.2. And let's do our other one. Now this came from this container. And I'm just checking to see if they give any specific directions. Again, we're going to let it dip it and let it sit for 15 seconds. Less than 15 seconds, actually, they say. Make sure you don't let it sit too long. Okay, so let's go back and look at this. So it looks like vinegar is even a lighter color than the lowest color on this chart. So it has a pH of less than 6. That's what I would say. And we would call that acidic. So I'm just going to call it sensor 1, sensor 2. So this one is a pH of less than 6. It is acidic. And up here, let's look at our color chart. I may have used the wrong dot. Let me check on that. Okay, it looks like on this sensor type, it's the third dot down that you need, so I just took it and cut the sensor so that I can easily dip where I need it. So I'm going to watch for a color change here. You can see the vinegar made it to the sensor. And then I'll match it up to my pH scale. And again, the lowest they give you on this is 6.4, probably assuming that you're testing water out of your tap, not vinegar. So the color is lighter than their lowest color. So again, I'm going to say less than 6 and acidic. So it really looks like these two sensors that I bought both at Walmart. One was more expensive than the other. They both work about the same. Probably they use the same compound immobilized on that sensing pad. So I would say go ahead and buy the cheaper one, the $5 test strip kit. You do only get 5 strips, so it's okay to pick 5 samples that I assigned and just test those 5 and report back about it. The reason this other kit was more expensive is it tests for more things. Okay, so the next sample will be baking soda. And our next sample is baking soda. So just to remind you what we talked about with vinegar, both the sensor types that I tried just now turned out to be the same. You can see the yellow color that developed was the same on both. So I'm just going to, from this point on, use the test strip that is made only for pH. That doesn't have all these extra dots on it. That's easier. I don't have to cut the sensor down in size. And I told you that I got it at Walmart for a certain price, but you can always use any universal pH sensor that you can find at a store. So you don't have to use the same one as me. As you can see, many of them work just the same. That same yellow color was produced for vinegar. So whatever you find, you can use to compare to your Cabbage sensor. So here we are trying baking soda. I have another piece of my Cabbage sensor, and I'm going to dip it in and see what color develops. I'll lay it down right here. And do we see any change? Well, it still looks blue like it was before, and I was saying I think my well water might be a little bit basic, but it still remained blue. So I'm going to write blue. Now I'm sticking to 2 different sensor types because I concluded these were the same. So for the Cabbage sensor, it turned blue. It remained blue. So I would say the pH is slightly basic. And now our next sensor. We're going to take and dip in to baking soda. Wow, it looked like a color change occurred there. And we're going to take it and match it up to the colors that we see. Looks like it matches pretty well with the 7.8. Somewhere around a pH, I would say somewhere around a pH of 8. And we would call that alkaline or basic. That's the other word for basic is alkaline. So it turned a red color. And the pH was about 8, basic. So both of them concluded it was basic. And we can see that our Cabbage sensors were a little bit less specific than this one, just simply because we don't have a color chart right now. If you look on Blackboard, you can look at that color chart and see if you can distinguish any more clearly. All right, and the next sample will be water. So we're going to test water first with our Cabbage sensor. I'll take and dip it in the water, and we'll see if we are able to detect a color change. And it looks still blue, and that's kind of what I was expecting because, of course, the cabbage sensors were infused into my water. So it looks slightly basic if you ask me. Okay, so I'm going to write that on my data sheet. Blue. Basic. Now, in theory, water, if it was pure water, it would be neutral. Now this is well water, which means there's lots of minerals, lots of ions in the water. If we were using distilled water, we would see maybe more of a neutral response. But let's look at our other sensor type and see if it can tell us anything more specific about the water. So here we have our universal pH sensor. We're going to dip it in the water. And we'll take it out. And we're going to let the color develop for a moment. So now this looks like it's able to say something a little bit more specific about the water than the cabbage sensor. Because the cabbage sensor, to me, just looked blue, just like it did with the strong base. But this sensor might be more sensitive. That's what it appears, because this color looks more similar to 6.8, 7.2. It's not quite as dark as the 7.8 was. So I would say that water, that our tap water, is closer to neutral than it is to basic, according to this sensor. So I'm going to say the pH is around 7 and it's neutral, which is more what you would hope for water. Okay, and that color was orangish. All right, I also have some lemon juice here ready to go. So I have our cabbage sensor. Let's dip it in the lemon juice. Any guesses about what color it might turn? Dip it in the lemon juice, and wow, there we go. You see right away, pink color developing, pinkish red, and that indicates that it is acidic according to the anthocyanins in the cabbage. So we see a red color, and that's acidic. So we have to remember our scale. For the cabbage sensors, let me just write a key here. For the cabbage sensors, if we have a pH closer to 0, we're going to see reds. If we have a pH above 7, we're going to see blues. And this is alkaline or basic. And below 7 is acidic. So this scale is different than the universal pH sensor that we're using here. It uses a different compound because the acids are red, the bases are red, and the acids are more of an orange to yellow. We saw vinegar turned yellow. So it's a different compound, it turns a different color, so we have to make sure we use the right scale. Okay, so we just tested our lemon juice. Now we're going to test it with the other sensor type. We'll dip it in our lemon juice and let the color develop. Now you can see it's very different from the neutral solution we just tested. And I'll move it up here closer to the sensor. So it looks like, again, we have a yellow color. It's even lighter than the lowest one on this scale. This is made for testing water, probably drinking water, so they wouldn't expect it would be any more acidic than 6. But we're testing lemon juice, so it's below 6. We have an acidic solution. So we're going to write here yellow, pH less than 6, acidic. Okay. Now we can test soap and hydrogen peroxide next. Okay. The next sample we're going to test is soap. I squirted some dish soap into liquid here, into water. I'm going to take my cabbage sensor and dip it in. We're going to look at the color that develops. And then again, we have a blue color. So we're going to note that down. And blue, remembering on our cabbage scale, is basic. So soap, the cabbage sensor blue. Soap would be basic. And then we're going to take our universal pH indicator, dip it into this soap, and find out what we find. Let that color develop. color sensors, similarly to what you're going to be doing in the next lab, lab number 13, are really a qualitative analysis rather than quantitative. If you really want to be quantitative about it, you would need a good measuring device that could give you the red, green, blue breakdown of each color, give you a very specific reading. But basing your results on the human eye and how well you can match a color to something else, it is difficult, and you can't be 100% sure that you're seeing it the same way as someone else. So we call that a qualitative analysis. It's kind of a ballpark analysis. We're going to do our best with each one though, and it's just to give you an idea. I know I can see it's not acidic, right? But whether it's closer to very basic or kind of basic, it's kind of relative. So I'm going to say it has a pH around, actually looks close to that highest one, doesn't it? I'm going to say it has a pH around 8. I'll say it's basic. And again, it's red. So that was our soap. So now you're going to be testing the same things as me. So fill in your data table, though, the best that you can. And I would like to see pictures of your sensors. Maybe you can lay your sensors next to your data table and take a picture of it so that I can see that you did the experiment and that I can see the color change that happened on your sensors. Some pictures of your Cabbage sensors with the color change, and some pictures of your universal paper sensor with the color change. That's what I'll be looking for to make sure that you did the experiment and that you analyzed it right. So if you saw red here, make sure, I would be checking to make sure that you made the right conclusion, for example. All right, and our last sample that we're going to test is hydrogen peroxide. So this is the same thing that you used in a previous lab. It's the stuff you can buy at the store. And we'll take our paper sensor, our Cabbage sensor, and dip it into the hydrogen peroxide. See what happens. No major change. So I'd either say basic or neutral. Now after analyzing the water that came up as neutral using the other paper sensor, I now understand that blue could mean somewhere between neutral and basic, so it's kind of hard to tell if we have a strong blue or a weak blue. There is a bit of a difference. This being the hydrogen peroxide, that being the soap. This may be closer to neutral, but it's kind of hard to tell. So again, the Cabbage sensors aren't quite so specific. So we have blue, and we're going to say it could be neutral to basic. And then we'll take our universal pH sensor and dip it in the hydrogen peroxide. We're going to be matching it up to the chart that we see. Okay. And because I ran out of the cheaper one, I used the other option that I bought in the store. And I should probably use the same chart that goes along with it, although I think the color scale is pretty much the same. Remember, we have a yellow color. It's actually quite yellow, which would be below 6 on the pH scale here. So that would make hydrogen peroxide, in this case, acidic. So this sensor is reading it as acidic. That's interesting. Okay, so these are the results. These are the results that I got. I'll be looking for you to submit your data sheet with all of your clear observations noted down, pictures of all of your universal sensor colors as well as your Cabbage sensor colors, and that's how I'll be assessing you. So that's it. Enjoy. Now, because I have Cabbage left over from the experiment when we made the sensors, I'm curious about how acidic this hydrogen peroxide is. I might take some Cabbage and set it aside and put some hydrogen peroxide on it. See if we see a color change. hard to tell. I think hydrogen peroxide to me appears to be close to neutral. Maybe slightly acidic. It looks like it might be turning a little bit reddish.